given here is given a value n, find the number of ways to make change for n cents if we have infinite supply of each s valued coins. And the example given here is that n is equals to 4, that is my target is equals to 4, and I have been given a array of m is equals to 3. So what do I do here? I simply take all these answers that have been given and I count the numbers. And how do I know these possible answers? So I'll be using recursion here, and after that I'll try to memorize it. So I'll just show the recursion and the memorization way on how to do it. So I'll just show the recursive tree that have been given here. So the recursive tree goes something like this. That is, I've been given this array that is 1, 2, 3, and I have been given the value of m is equals to 3 and n is equals to 4. So I need to actually find this value right here. This m is equals to 4. So what can I do? I have multiple choices either to choose or not choose. So I can go to the first index that is equals to 0 and choose the value 1 multiple times, or only one time, or two time, whatever. So I'll go there at the first index and choose 1. I've chosen 1. Then again I can choose 1, again I can choose 1, again I can choose 1. So if I get the value which is equivalent to n, that is 4, so after I sum it up it will give me n is equals to 4. So I indeed return a value 1. That means I can get a possibility that this way I can sum all these numbers, that is 1, in this way, so that I can indeed get a value which is equals to n is equals to 4. So I've got one way. Let's see the other way. That is, I do not choose 1, so I discard this one here and I try to take 2 here. I'll try to take 2 here. That is, I've chosen this 2. Again, I can choose this 2. That is this. So again, I get the value which is equivalent to the value again 4. So again, I get another way to make the sum which is equals to 4. Now again, I want to not choose it. That is 3. So what will I do? I'll say I'll not choose 1, I'll not choose 2 either, and I'll choose 3. So I'll just go here and take on 3. And after that, what do I say? I say in the next time I'll choose 1. Since we have infinite supplies, so we can take any number of elements anytime. So I'll choose 1. So which in turn gives me a value 4 again. So here I took 2 and 2. Here I can also take 2, 1 and 1. So this in turn also gives me a value which is equivalent to 4. Well, I had not written that because it was getting quite big. That is why I did not write it. But this is also a case in which we can do it. So we will get what? 1, 2, 3, and 4. So we'll get total 4 ways in which we can do it. And this is what we have to return. And this was it for the explanation. I'll just go through the code once, and I'll make another video for the DP approach that we can do here. This is memoization and recursion. So if n is equals to 0, that is return 1. Why did I do this? What is n? So here I added up, right? I was adding up the numbers. So I can also do by subtracting it. And why subtracting also works, since I know the value that I've got here, let's say, is 4, right? So if I take 1 4 times, what do I get? 4, which in turn leads to the value 0. If I just subtract them, that means if I have a value 4, just ignore this, I choose 1. So what is my current value? 3. If I say again I'll choose 1, what is my value? It will be 2. Again I choose a value 1. What will be my value? 1. Again if I choose it, what will be my value? 1 minus 1. That is indeed 0. And if I reach 0, that means yes, this index guy did give me a value which was equals to 4. So this is why n is equals to 0 returns 1 here. So I'll be explaining like this if anything is complex. So now I move on to the next part, that is dp of in is not equals to minus 1, then return this. So this is a simple memoization step, nothing too complex about it. So if I have already calculated the value, so I can just return this simply. And if I is less than or equals to 0 and n is less than or equals to 0, we return 0. Why? So if my n is equals to 0, so if my n is equals to 0, I know I do not need to find any answer for it. Since my sum is equals to 0, why should I take any coins from here? I'll just simply not take any coins. That means I can get a value of 0 here. And if the value of n is less than 0, that means while I was subtracting, so I got someone which led me to a negative value. That means if I have, let's say, n is equals to 4 and a combination I was trying a combination. Okay, this is not working for some reason. I'll just write this up here. Let's say if I was trying some combination for 4, I want my summation to be 4. I was trying something like I subtracted 3 from it. Okay, so I got 1. Now again I wanted to take 3. Can I take 3? No, obviously, because if I subtract minus 3 from 1, what will I get? I'll just get minus 2, right? So this is not my desired answer. So if this is the case, we return 0 indeed. And this is what I've done right here. And if m is less than or equals to 0 and n is greater than or equals to 1, I say return 0. And why? So m is less than or equals to 0. What does that mean? That means there are that is the last indexed guy, and I do not need to take anyone further. And if n is greater than or equals to 1, that means since I've taken n as 1 based, that is why n is greater than or equals to 1. So I do not need to go further. And this is a simple recursive technique that I've used here. I just choose one and I do not choose one, which I showed you previously in the recursive tree here. We choose one and we do not choose one. And if I get a value which can be taken into consideration, I can choose that value also. So that is what I did right here. My pen is not working, otherwise I would have showed it to you again. But I think you must have got the point while I was explaining it. So I just choose here. So when I choose, I can again choose that. That is why I've not taken minus 1 here. And if I don't want to choose it, that is why I've taken I minus 1. So this is what the recursive code is. And this will run. If you want, you can just copy it. I've just extended the code. If you want, this is the code. And yeah, that is it. Thank you for watching.